Destruction effects, such as explosion, shattered objects, are very common in movies and increasingly popular in video games as well. Physically based fracture methods are usually very slow, tedious to tune, and also difficult to integrate into 3D modeling software such as Maya. We want to develop a fracture tool that is integrated with Maya, provides users with maximal control over the results, and also easy to use even for people who have no knowledge of fracture at all. Our tool is capable of producing global decomposition of objects, local fracture according to impact conditions such as impact position and radius, provides procedurally generated spiderweb pattern for user to choose, import user-defined pattern for fracture, and provides option to set up Maya rigid body dynamics automatically. For global decomposition, user only needs to set the number of decompositions. Then the decomposition cells will be automatically generated. To achieve impact effect, user can select a vertex on the mesh as the impact position and set the impact radius. The impact radius affects the degree of impact. User can apply our procedurally generated spiderweb pattern to any object. In order to apply spiderweb pattern, local fracture has to be enabled, and the impact position has to be selected. Users can easily set up a simple rigid body simulation by enabling the rigid body option. Here are some example results. On the top, two balls have different impact radii. On the bottom, the spiderweb pattern is applied. Here are some examples with more complicated geometry. This particular Stanford bunny mesh consists of over 20,000 polygons. Our implementation is based on the 2013 SIGGRAPH paper, Real-Time Dynamic Fracture with Volumetric Approximate Convex Decompositions by Mueller et al. We modified their workflow mainly because our tool is a Maya plugin rather than a standalone application. And we use Maya Dynamics to perform rigid body simulation. First, we import the data from Maya including the mesh, fracture pattern type, impact position, number of decomposition, impact radius, and so on. Next, we convert Maya mesh to vMesh, our mesh data structure, and generate pattern cells according to fracture type, impact condition, and other parameters. After that, we first clip the global decomposition cells against vMesh using Boolean intersections. And then, we align local pattern cells to impact position and clip against the affected piece. Finally, we convert the resulting mesh back to Maya mesh.